Okay, geometry students, today we're going to talk about set theory. We have some vocabulary to go over. A set is a collection of elements, for examples, numbers, colors, people, etc. Here's an example of a set. We have the colors red, orange, yellow, and green. A universal set is a set with all possible elements. A universal set that we can talk about is a universal set of digits. All of our digits are represented here from 0 to 9. A subset is a set with elements from the universal set. So if we talk about our universal set of digits, a subset of that universal set might be 2, 5, 7, 8, and 9. Okay, let's talk about the relationships of the set. An intersection is the elements that the two sets have in common. Think of intersection as and the symbol is like that. So for example, we have set C, which has 7 and 8 in it, and we have set D, which has 7 and 11 in it. So the intersection of set C and D would be the number 7, because it's the number that they have in common. Let's talk about the union of the elements. A union is when you have elements from both sets, but they don't repeat. So think of the union as OR, and its symbol is like this. So if we look at our example C again, we have 7 and 8, and our example D, which has 7 and 11. The union of 7 and D is going to look like this: 7 and 8 and 11, but it will not have that 7 repeated. All right, the complement of sets are when you have elements from the universal set that are not in the given set. So think of the complement as not. And its symbol is A with a hash mark there, or A with a line above it. So if we talk about, again, our universal set of digits, 0 to 9, and our subset of digits, 2, 5, 7, 8, and 9, our complement, or our elements that are not represented in our subset, would be the numbers 0, 1, 3, 4, and 6. So keep in mind, a set and its complement should form the universal set. All right, let's take a look at some examples on the back. We have a large bag that holds marbles of the following colors: blue, green, orange, and pink. A small bag holds a marbles of the following colors: red, green, yellow, and orange. So let's talk about the universal set. Our universal set includes the colors blue, green, orange, red, and yellow. Now we have two subsets of the universal set. We have our large bag, which contains the colors, we use abbreviations this time, blue, green, orange, and pink. And we have our small bag, which contains the colors red, green, yellow, and orange. Okay, let's draw a Venn diagram to represent the universal and the two subsets. So in our Venn diagram, we're going to need two circles. A circle here, and we have another circle here. One circle will represent our large bag, and the other circle will represent our small bag. In the large bag, we have blue, and we have pink, but we also have these shared colors, green and orange. In our small bag, we have red, green, which is already represented, yellow, and orange, which is already represented. So there is a Venn diagram that represents the universal and the two subsets. And the intersection and union of these subsets. So if we have our large and our small, that will give me the green and the orange that they share. If we talk about the union, large or S, sorry, that shouldn't be a U, large or S, it's going to include the colors green, pink, blue, orange, yellow, and red. So let's talk about the next example. We have a universal set consists of all of the single-digit positive whole numbers. Two subsets are created from the universal set, the set of all even numbers, E, and the set of all multiples of 3, M. So let's talk about the universal set. So our universal set is going to be the numbers 0, 1, 2, 3, 4. So there's our universal set of digits. Number 6 says define the two subsets. So I'm going to have the two subsets. We said we wanted the even numbers. That's going to be 0, 2, 4, 6, and 8. And then we wanted our multiples of 3. We'll call that M and maybe put a 3 there. And that's going to be the numbers, or the digits, 3, 6, and 9. Okay, so number 7 wants us to draw a Venn diagram to represent these sets. So we're going to have two circles in our Venn diagram here. We're going to have all of our evens in one, and then our multiples of 3 in the other. So all of our even numbers include 0. Sorry, we don't need the parentheses there. I mean the comma there. 2, 4, and 8, and they share 6. My multiples of 3 are 3, 6, which we have represented there, and 9. Now we do have 3 numbers that aren't represented in either one of those sets, so we're going to put those on the outside here. We'll put a 1 here, and then maybe a 5 here, and then a 7 here. Okay? Now we're going to find the complement. Oh no, yes, let's find the complement. The complement of our universal set, and that is going to be the digits. I'm not sure what's wrong with my board today, but we're going to ignore that. Okay. Includes the digits 1, 3, 5, 7, and 9. The intersection of our two elements is going to be, so E is just going to be the number that they have in common, which is 6. And then we're going to find the union of our two sets. And that's going to be 1, 5, and 7. Okay, that's it. Have a great night.